Welcome to the Explainer. Today, we're going to crack open the Data Analyst's digital toolbox and take a look at the essential techniques that are really powering modern business insights.
Have you ever wondered how businesses seem to predict what's going to happen next? Like how a hospital has a pretty good idea of which patients are likely to be a no-show for their appointment, or how your streaming service just knows that because you binged a true crime documentary, you're probably going to love some obscure historical drama, and then, bam, there it is, right on your home screen. Well, the secret lies in a set of really powerful data techniques. We're going to look at the tools for prediction, for finding patterns, and for simplifying complex data. We'll also peek at the new frontier of AI, and then, most importantly, we'll talk about how you choose the right tool for the job. So, how do we predict the future? Let's dive right into our first set of tools, the ones specifically designed for forecasting. One of the classics is a tool called ARIMA. Think of it like a crystal ball for any data that happens over time, like sales figures or stock prices. It works by looking into the past for stable trends and seasonal patterns, a concept called stationarity, and then it uses that rhythm to project what's coming next. The whole process involves checking for that stability, stabilizing the data if you need to, finding the right settings, and then letting the model make its call. Now, for a totally different kind of prediction, analysts use decision trees. And these are awesome because they brilliantly mimic how we humans make decisions. They create a simple flowchart that just asks a series of if this, then that questions to get to a conclusion. This makes it incredibly easy to understand why a certain prediction was made. But what's absolutely crucial to understand about decision trees are their limits. They are fantastic for classifying things, like predicting if a patient is a no-show risk. But they can't tell you the root cause. They show you there's a connection, but not that one thing caused another. It's all about correlation, not causation. Okay, let's switch gears from prediction to discovery. Now we're looking for hidden patterns in our data. These are the tools that act like magnifying glasses, revealing connections that just aren't obvious at first glance. The simplest tool here, and often the very first step in any exploration, is correlation analysis. It quickly answers a really fundamental question. When one of these numbers goes up, what does the other one do? Do they move together, in opposite directions, or not at all? But to find more complex co-occurrences, analysts use association rules. This is the secret sauce behind market basket analysis in retail. It generates those really powerful if-then rules that help businesses improve where they place products, how they design promotions, and ultimately how they increase the average basket size. So what if you don't really know what you're looking for? What if you just want to find natural groupings in your data? That's exactly where K-means comes in. It's like a lightning-fast sorting machine. You just have to tell it how many groups, or K to find, and it sorts your data into the most logical clusters. But K-means has a clever cousin called dbScan. While K-means is great for finding simple, round, blob-shaped groups, dbScan is much better at finding odd-shaped clusters based on how dense the data is. And here's the kicker. It's fantastic at spotting anomalies, things like fraudulent transactions, and labeling them as noise instead of forcing them into a group where they just don't belong. So, what happens when you have too much data? Hundreds of variables, all potentially related. You reach for tools that simplify that complexity, tools that act like prisms and reveal the underlying structure. Factor analysis is perfect for this. Imagine you have a 40-question patient satisfaction survey. Instead of trying to analyze 40 different answers, this technique can distill them down into just a few core themes, like staff courtesy, wait time, and communication quality. It just makes the results so much more actionable. But simplification isn't just about numbers. It's also about translation. I mean, how do you take something messy and unstructured, like a doctor's clinical notes, and turn it into a format that a machine learning model can actually work with? The answer is feature extraction. This is the absolutely critical bridge between the raw, messy world and the clean, numerical world of machine learning. It's the process that turns words, images, and sounds into meaningful numbers, and it really is what makes modern AI possible. All right, now we're at the cutting edge. Let's explore the most powerful and flexible tools in the entire toolbox, the ones that are defining the new frontier of artificial intelligence. First, let's clear up a broad term you hear all the time: data mining. This isn't a single technique. It's really the entire philosophy of exploration, the whole process of digging into massive datasets to find those valuable hidden insights. In fact, it's an umbrella term that includes many of the tools we've already discussed. Clustering, classification, association roles, they're all part of the data mining process, and they're all aimed at extracting value from data. Then there's deep learning, which is the engine behind most modern AI. It's incredibly powerful at finding complex patterns in images or text, but it is also incredibly data hungry. To be effective, these models often require a staggering amount of data to learn from. We're talking millions of examples. And this power leads us straight to generative AI. This is a revolutionary step. These models don't just predict or classify, they create. They learn the underlying patterns of data so deeply that they can generate entirely new and original content, from text and images to synthetic data for training other models. With all these powerful options, from simple correlation to complex generative models, the real skill for any analyst is knowing which tool to grab from the toolbox for the specific job at hand. And this right here brilliantly illustrates the central trade-off that every analyst faces. Simpler models, like decision trees, are highly interpretable. You know exactly why they made a decision. On the other hand, a powerful deep learning model might give you a more accurate answer, but its reasoning can be a complete black box. So what's the ultimate takeaway here? The true power of data analytics isn't about mastering the most complex tools. It's about mastering the art of asking the right questions. Because when you know the question, you'll always know which tool to reach for.